All right, this is day one of the notes for section 6.5 for PCM, Systems of Inequalities. For our vantage point, our purposes today, we are just going to look at single inequalities, and then for day two notes, we'll look at actual systems. So inequalities, as you may or may not remember, we're dealing with less than, greater than, less than or equal to, or greater than or equal to. So in this case, for this problem, we got x greater than 3, and that is going to be a dotted line. Dotted line because there's no equal to there, and so that line is a vertical line. Notice we went to 3 on the x-axis, put in our vertical line, and again it's dotted because there's no equal to. And then when you shade, the easiest way to go about this is to do something called a test point. And so I usually will use 0, 0. In fact, probably should have wrote that in here. So 0, 0 is usually the test point we'll use. There are cases when you can't. We'll see that in a little bit. But if I plug 0 in here for x, I'm going to get 0 greater than 3, and that is false. What that tells me is that I am not shading towards 0, 0. That greater than 3 is actually this region right here. And so do you need a test point? No, but it's a good idea. Again, pick 0, 0 because it's the easiest point you could pick for substituting into an inequality. And if it's true, you shade towards your test point. If it's false, you shade in the opposite direction. So our next one here, now we have y instead of x greater than or equal to. So now because it's greater than or equal to, solid line. And because it's y, that is going to be horizontal. Again, with our test point here, we used 0, 0, and that's pretty standard. So if I plug 0 in for y, in this case, since there is no x, 0 is less than or equal to 4. That is true, and so this time we are going to shade towards the test point. So this bottom area here. Okay, our next example, now we actually get to a full-fledged linear inequality where we have x and y. You can see this is in slope-intercept form. So I have a y-intercept of -5. I've got a slope of 1/2. So I'll keep going up 1 over 2. This is a dotted line because there's no equal to. And we want less than. So if I use my test point of 0, 0, and I plug 0 in for y and 0 in for x, you can see that is false. So we are going to end up shading down here. And as you can see through the magic of technology here, now that image is shaded. So we shaded away from 0, 0 because that was false. So that's this region that is underneath this dotted line. These inequalities will work for non-linear equations as well. So on our next page here, you actually see a quadratic. So we have x squared minus 6. Just like graphing x squared, you know x squared normally starts from 0, 0 and opens up. We just moved all our points down 6 units. So instead of 0, 0, we have 0, -6, then up 1 over 1, 2 squared is 4, went up 4, then up 9. So we just mirrored those points here. This is a solid curve, again, because it's greater than or equal to. You can see our test point here, 0, 0. And when I plug 0, 0 into this equation, we end up with 0 greater than -6, which is true. So we are going to shade inside the region, or the region that's inside this quadratic. And again, as you can see, once we have our test point, we know that it's true. We're going to shade towards that point. So that's the region that is inside this parabola. No need to go past the parameters of the graph. That's okay. I mean, we could have continued these lines, but that's really not necessary. So I think the understanding there is that's the area inside of the quadratic. If this was false, then we would have shaded all of this region out here. Circles. May have been a while since we've done these, but here's the equation of a circle. We got our center point at HK, got our radius at R. You can see that this particular graph, x squared plus y squared less than or equal to 16, our center point's at 0, 0, and our radius here is 4. When you graph a circle, really there's 5 points that you're concerned with. First and foremost is the center point, so in this case 0, 0. Then our radius being 4 units, we can go to the left, to the right, up, and down. Now, obviously, I have the benefit of the smartboard, and I have a circle drawing tool here, so I can make mine look pretty good. As far as your homework, or if you're doing this on a test or quiz, just draw it to the best of your ability. Obviously, from my vantage point, I don't want a diamond here. Don't just connect the dots straight, but do the best you can circle-wise. Now, I didn't show the test point, but if we look at 0, 0 here, if we were to put 0 in for x and y, since that is the center point, it's clearly inside the circle, and 0 squared plus 0 squared is less than or equal to 16. So our region that is shaded is actually the area inside that circle. Now, if this was greater than or equal to 16, we would have shaded outside here, because then we would have got 0 greater than 16, and that's false. But since it's less than or equal to inside the circle, if it was greater than or equal to outside the circle. Another circle example here. This time I purposely put the center point outside of 0, 0. Again, that was done intentionally for 2 reasons. One, so we're not just dealing with the origin as our center point, and 2, 0, 0 is actually on this circle, so now I can't use 0, 0 as a test point, but we'll get to that momentarily. So the center point here, remember your center point is always the opposite of what's in your parentheses for a circle. So our center is at 3, negative 4. Our radius is at 5. So I graphed my center point right here, and I went 5 to both the left and the right, and 5 up and down. There's no equal to here, so be careful. This time this circle is dotted. I can't use 0, 0 because 0, 0 is actually on this circle. So that point's not going to help me. So now I have to pick a different point. Typically, if we can't use 0, 0, we'll look at either 1, 0 or 0, 1. Well, 1, 0, we could have used that one. I just used 0, 1 here. So 0 for x, 1 for y. And what we find out when we do that is we get 34 greater than 25. That's true. So we're going to shade towards this point. So it winds up being the area outside of the circle. So I kind of cheated and created this ahead of time, but what you got here is this blue area outside the circle is actually our shaded region. And everything inside the circle is not going to work. So that's our notes for today for 6.5 day 1. I will post day 2 here later this week. But you have your homework worksheet for 6.5 day 1, so you get started on that as well as the review worksheet. And we'll talk to you later.